Hello and welcome to the introduction video for mBFR. Let's begin. Have you ever experienced any biofouling trouble in your RO plant? Toray has developed the original innovative water quality evaluation indicator for RO feed water, membrane biofilm formation rate, mBFR. mBFR can predict concerns and risks of biofouling in advance, and it can also contribute to quickly identify the cause and resolve issues when fouling problems occur. The measurement method is quite simple. Simply connect the mBFR measuring column kit to the sampling point of the plant and let the target water flow vertically from bottom to top at a constant flow rate. No special construction work or shutdown is required. When biofouling occurs, problems such as increased pressure loss and reduced permeate flow are caused, and frequent chemical cleaning or membrane replacement becomes necessary. To significantly reduce operational costs, it is essential to predict and take preventive measures before the problem arises. As the biofilm develops, brown, sticky organic matter accumulates within the elements, obstructing the flow paths. When water passes through the RO element, some bacteria are adhered and use the nutrients in the water to multiply, produce EPS, and grow the biofilm. Biofouling occurs when the biofilm exceeds acceptable limits. All bacteria contain ATP, which provides energy for metabolism in living cells, and can be measured very sensitively using firefly luciferase. Measuring the amount of microbial-derived ATP on the RO membrane surface over time, it is possible to predict the biofouling potential. mBFR is defined as the rate of ATP accumulation per day. Firstly, original separable columns that simulate RO membrane surfaces are prepared, and ATP attached to the RO membrane piece inside the column is periodically measured. As a result, the slope of the line represents mBFR value. The rate of ATP accumulation, that is, the magnitude of the mBFR value, is related to the level of biofouling risk. A high mBFR value indicates a high biofouling potential of the water, while a low value indicates a low biofouling potential. For example, there are two actual plants measuring mBFR and differential pressure during the same period. It is revealed that at high mBFR plant, the differential pressure is gradually increased, and earlier RO chemical cleaning may be needed. As a result, mBFR value has good correlation with the actual operating conditions of the RO plant. mBFR is useful for roughly predicting the frequency of chemical cleaning. Based on Toray's experience, it is recommended to maintain mBFR below 10, ideally below 5, to minimize chemical cleaning frequency and prolong the lifespan of RO elements. Utilizing mBFR, plant operation can be proactively managed and optimized. mBFR is useful for troubleshooting. When the biofouling potential is high, adding biocides such as DBNPA can be used as an effective countermeasure. However, determining the optimal dosage rate can sometimes be challenging. Measuring mBFR, it can be optimized that the dosage rate of around 20 mg per liter is neither excessive nor insufficient. mBFR is a reliable indicator that enables to utilize both biofouling prevention and biofouling troubleshooting. Our professional technical experts have always helped solve your needs. With this, we have finished introduction of mBFR. Thank you very much for your attention. If you have any questions, please don't hesitate to contact us.